Example 2 says hydrogen gas reacts with fluorine gas to form hydrogen fluoride. Using bond energies, calculate the heat of this reaction. So here I have balanced and completed my chemical reaction, and I am now going to draw out each of the Lewis structures. So for two hydrogen atoms, it is bonded by a single bond. And this is the molecule for H2 gas. Fluorine looks like this, the fluorine gas. So you should see that for one fluorine atom, there are 7 valence electrons. Since there are 2 fluorine atoms, there is a total of 14. So if you add up all of these electrons, as well as consider that the single bond has 2 shared electrons, we have a total of 14. And for your hydrogen fluoride, we have 2 of them. Again, because if we consider our balanced reaction, there's a coefficient of 2, so that means 2 molecules of HF are formed. Now that I have my Lewis structures, I can then use my reaction equation, delta HR. This symbol here just represents delta H of this specific reaction. So again, my equation is sum of the energy of bonds broken, subtracting sum of the energy bonds formed. So first, the bonds broken. There's 1 mole of my H2 gas bond, 432 kilojoules per mole, plus 1 mole of my fluorine gas, and the bond energy for this is 154 kilojoules per mole, minus the bonds formed. So because 2 moles of hydrogen fluoride are produced, I need to take that into account. There are 2 HF bonds that are formed. So that's why here I'm writing 2 times 565 kilojoules per mole. Okay, so you can see here, this calculation is associated with my 2 HF bonds. This calculation here is associated with my fluorine gas. And then this calculation here associated with my H2 gas. So after calculating the sums and then subtracting them, you will get negative 544 kilojoules as the heat of this specific reaction. If the question asks to determine the heat of the reaction when hydrogen reacts with fluorine to form 1 mole of hydrogen fluoride, your reaction is going to look different, and the delta HR is going to be different as well. So if you notice in this first reaction, 2 moles of HF are produced. So for 1 mole of HF produced, your balanced equation is going to be 1/2 H2 gas plus 1/2 F2 and 1 mole of HF gas. So now if the question said solve for the heat of this reaction, you would multiply your bond energies by 1/2 for H2, 1/2 for F2 bond energies, and just multiply by 1. Because it is exactly half, all of the coefficients are half of the coefficients from this reaction. The delta HR is just half of the delta HR of this calculation. So it will end up being negative 272 kilojoules. Okay, and again, I'm just showing you this specific equation. Let's say if a question asks, for 1 mole of HF produced, determine the heat of this reaction. We need to consider that there is a more simplified version of the above reaction, which is shown in green here.